Today's lesson is about function families and their characteristics. Now first, a function family is just a set of equations or functions that all have the same characteristics. In this class, we're going to learn about 4 different functions. We're going to learn about linear, which you've already talked about before in middle school. We're going to learn about quadratic, which is new here and a big part of Algebra 1. We're going to learn about exponential and spend a few days on that. And then the 4th one we'll learn about is the absolute value. The absolute value we don't spend much time on. We spend most of our time just learning about what it's going to look like and some of the basic characteristics of it. You spend more time on Algebra 2 on absolute value than we do here. Our first function family of the day will be linear. Linear as it sounds, made up of lines. And the parent function is y equals x. Now, a parent function is basically the most basic function. It's where all functions come from. In fact, some people like to call it the mother function. Now, in this case, y equals x is the line that you've most probably dealt with the most. It's just a simple graph like this. It has a slope of 1, starts at the origin, very, very basic. Some other examples of linear functions would be y equals 3x. So you have the x with an exponent of 1. You have y equals negative 4x, or y equals 1/2 x. Or if you start changing it, moving it up and down, changing the y-intercept, you have things like y equals 2/3 x minus 3, or y equals 8x plus 9, things like that. Anything with an x with an exponent of 1 will be linear. Our next function family is going to be quadratic. Now, quadratic, as I said earlier, we spent a lot of time on that later in the year, but the parent function for a quadratic equation is y equals x squared. Notice the exponent of 2. What that does is cause the graph to be this U shape. Okay, it's not quite a straight point, but rounded down here at the bottom at what we call the vertex. Some examples of quadratic equations: we have y equals 3x squared, y equals negative 4x squared, and then we can start throwing some more pieces in there. So like y equals 1/2 x squared minus 3x plus 5, or y equals negative 2/3 x squared minus 17. These are all examples of quadratic equations. Our next function family will be absolute value. Now, as I said earlier, we don't spend a lot of time on absolute value. We basically want to learn just that's the basic characteristics of it. But if you remember from middle school, absolute value are these 2 straight lines, usually with a number inside of it, and it means the distance from 0. An absolute value equation will look something like this. Instead of a number inside the bars, it'll be a variable, x. So that is the parent function, y equals the absolute value of x. And a absolute value graph has the shape of a V. It looks like 2 lines that have the same endpoint. It's not, it's one graph, but it has that look. Some examples: y equals the absolute value of 3x. Y equals the absolute value of negative 4x. Y equals negative absolute value of 1/2 x. And then you can add the pluses and minuses in there. So y equals negative 2 absolute value of 3x minus 7. Okay, so you can do all sorts of things with it and still have absolute value. The next function family we'll deal with is the exponential functions. And again, we'll spend some more time on exponential later in the year. The exponential parent function looks like this: y equals 2 to the x. Now I put 2, normally we put maybe another variable in there, but the difference is between exponential and all the others is that in exponential, the exponent is a variable, whereas in the others, the exponent would be a number like 1 or 2, or in the case of absolute value, may not have an exponent. But in this case, the exponent is the variable, so it changes rather than the base. And the function looks like this. And it can go a lot of different directions, and we'll look at those later. But some examples, we have y equals 5 to the x. We can have y equals 3 and then parentheses 4 to the x. Okay, we can do all kinds of things. We can even add y equals 2 plus 7 to the x, things like that. Okay, that'll just about do it for the video. For the rest of the assignment, what you're going to do is when you get to class, immediately go and pick up a calculator from the caddy. Choose wisely, because whatever number you choose, that's the number I'm going to assign you for the remainder of the year. Then, with your partners, if you'd like, you're going to go to the graphing section, and you're going to put each one of these equations for linear, quadratic, exponential, and absolute value into the calculator and graph them, and then just do a sketch. Okay. Now, if you haven't ever used those calculators before, you're going to go to the y equals button. It's at the top left. You just press it, type in the equation. If you need any help, please ask. I'll be in the room. And then you're just going to sketch it. For example, for the second one there, y equals negative 3x plus 5, you do not have to graph the actual points, but you'll figure out that it crosses the x-axis right there and looks kind of like this. And that is enough. I didn't draw any points, maybe the x-axis or the y-axis, but that's about it. But do that, sketch each one of them so you have an idea, and then I'll give you some further instructions. But what you're going to do is, in your group, you're going to compare all the graphs, and you're going to start writing down some characteristics you notice about each function family. You write down as much as you can, as many things as you can. That's it. Thank you very much.